All right. I would like you guys to look at this two graphs here. It says this is a continuation of chapter 2. Explain what's misleading about the graphic. Somebody is making the claim that the volume of sales has doubled from here to there. So they claim that it has doubled. What's wrong with this? Why this graph, guys, do you think is misleading? Anyone can tell me.
Let's see. The length of a site is doubled, but the area has been multiplied by 8.
Is the area by 8? Okay, so do
No.
you guys agree? Do you guys agree with me that this picture is a lot more than double of that one?
Yeah.
So
Yeah.
that's a
Yes.
wrong message. But what is it what did the guy do to mislead people? What was he thinking? What did he do? If somebody asks him, just you're lying to us, he has an answer to this. What did he do? But he ended up misleading people.
He doubled both the length and the width.
Exactly. He doubled both the length and the width, but he didn't know that the area it's gonna fire up and go 4 times as much. How many units do you have here, guys? 1, 2, 3, 4. If he wants to put an accurate graph, he should draw 8 boxes because 4 to 8 is double, but he didn't do that. He doubled the length, he doubled the width, he ended up with 4 times the area. Look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I have 4 boxes here, I have 16. This is 4 times as much. That would be the answer. This is an example of a misleading graph. Let me show you another example. What's misleading about this graph? I did mention that briefly last time, so that any graph that starts, you see that scaling here, guys? When you begin scaling, what should you start with?
0.
0. We didn't begin with 0. So that is a misleading graph if you don't begin with 0. So please remember that any vertical scale that doesn't begin at 0 is misleading.
What about that symbol you showed us that shows that it doesn't start at 0?
Oh, for this. But these are years, are not numbers, so it's okay. You don't have to start at year 0. It just listed years, nominal, so that's fine. But you're right. If these were numbers, like 0, 5, 10, 5, 10, 15, he should have, if he didn't start at 0, counting from 0, he should have put that break up simple. Exactly.
Oh, so but you're saying you have to start at 0 for a vertical axis, though?
Exactly. Only the vertical axis, because this is where the frequencies are.
Okay.
The horizontal axis has labels sometimes on it. It's not always numbers, so it's okay. And for the years, well, you don't expect to start at the year 0 because this is when we started counting, just years, Gregorian time. So that's different. But if they put this, that will be nice as well. But the big problem here that he didn't start the vertical axis at 0. I'll show you another graph here, guys. I'm gonna show you this. You see how misleading graphs. Last year, this year. Okay, look at this graph, guys. Somebody is trying to make a claim, for example, sales, that they increased their sales from last year to this year, and they show this graph. This is a big misleading graph. What's your first impression, guys, when you look at the graph? Don't look at the vertical line.
You didn't put number like on the last year and the next year. You didn't put
Yeah,
any
but
number.
what's the impression when you look, compare the two graphs? What do you feel?
The question
The
is that it
sales.
doubled.
The sales have doubled. Doesn't look like, you know, the big graph is twice as big. Yes, it looks. So if you guys don't look at the vertical axis, you're gonna make an impression that this guy, let's say he sells cars. If he sold 50 cars last year, this year he sold 100 cars. But look at the numbering here. I didn't start at 0. I put a 10,000 here, and look what I put there, 11,000. So the scaling, you know, just is not proper there, and you can mislead people. So actually, yeah, the sales has gone up, guys, but not as we think. It's doubled. It's only 1,000 from 10,000 to 11,000. It's only 1,000, but this is a misleading graph. The reason why I put those two questions there, guys, I'd like to make you aware that when you see graphs from now on, take a careful look at it, and you might, very likely, you might find something, you know, just that is misleading, you know, about the graphs. Because marketing is all about misleading people to believe, you know, just in the product that people trying to market. Probably it could be a good product, but people are going to do their very best, you know, just to sell you the product. And this is something that you should be aware of. All right. One more thing I would like to do before we begin section 2.3, guys, because this is something you're going to come across later. All right. Okay. I'm going to do this table, frequency table. Okay. Let me just put 1 to 5, 6 to 10, 11 to 15. Can you tell me, guys, what the class width is here?
5.
That is correct. And you guys, you don't subtract this from that, you subtract these two. So if you have that table, guys, you know that the class width, you don't need to do any work. The difference between 1 and 6 is 5.
Sir, I have a question.
Yes.
So we can't like say like, so the first number was 10 and then you put 10, then 15. So it's 5 extra like every time. 5 plus 5 plus 5. We can't do that?
This way. Yeah, this way. Yes. Yeah, you can.
Okay. Thank you.
Yeah, sure. Okay, let me put some frequencies and ask you another question. Okay, if I ask you guys, what fraction of people have a score between 6 and 10? How would you answer this question? How many did they have a score between 6 and 10 inclusive?
5 out of 20.
5 out of 20. So you need the total, guys. This is called sum of frequency. If we add them up, that's 20. And when I ask what fraction, this is called the relative frequency. So this is 5 out of 20. I think, guys, you agree this is 7 out of 20. This is 4 over 20. And this is 4 over 20. So this is what we call relative frequency. Now, let me introduce something new that's not very important, but you will come across this. It's called the cumulative frequency. Just 1 second. Okay, let me tell you a little bit about the cumulative frequency. Here's how you do a cumulative frequency. If you're asked to do a cumulative frequency, you already have the frequency. The cumulative frequency from 1 to 5 is 7. Now, The cumulative frequency for 6 to 10, it's everything from 6 to 10, and that came before as well. So what do? You do 7 plus 5, which is 12. The cumulative frequency for 15, it's everything between 11, 15, and everything that came before. So that will be 4 and 5 and 7, which is 16. And I think you can guess the last class, what is the cumulative frequency. The cumulative frequency is this class and all the classes before. So it will be 4 plus 4 plus 5 plus 7, and that will be 20. So that's what a cumulative frequency is. Let's see, I have some chats here. So this is what we call cumulative frequency. So if you guys, if you're asked while doing the homework to complete a cumulative frequency, for the first class, it will be the same as this. For the second one, you just add these two. For the third one, you add 1, 2, 3. Yes.
The shadow bar is blocking the screen.
Thank you. And for the last one, guys, you add 7 plus 5 plus 4 plus 4. This is, and you know, cumulative, guys, means everything. So you just keep adding everything. So that's what a cumulative frequency is. So you start with 7 and then 12, and then it goes up. A cumulative frequency is going to go up because you keep adding. Okay, so that is the frequency table. One more thing I want to remind you that we did last time as well, guys, is the midpoint. How do you find the midpoint between 1 and 5 halfway through? Can you guys remind me how we did that?
1 plus 5 divided by 2.
Exactly. It's 1 plus 5 divided by 2. So the midpoint for this will be 1 plus 5 divided by 2, which is 3. Look, guys, you don't need to do 6 plus 10 divided by 2, 11 plus 15 divided by 2. Just the class width is 5, so start adding 5. That's all you need to do. So that will be 8, and that will be 13, and that will be 17. These are the midpoints. All right. Okay, one more thing, and then we'll begin section 2.3. When you have a histogram, if you have this question, that's one of my favorite questions that I ask always. So I'm just going to bring it back to your attention. Let's say I give you this on a test. Okay. How many classes do we have here?
3.
3 classes. Okay, good. What's the class width?
6.
6. Does everyone know how your classmate answered 6? Because she did the difference between 10 and 16. It's 6. 16 and 22 is 6. Now the question is, I want the first class. What is it? From what to what? From 2.
From 0 to 10,
No.
10 to 16.
10 to 16, that wouldn't be, you see, if you go 10 to 16, it goes to here, and then it goes to the second class. We need to stay here.
Is
So it looks like it's going to be a number below 10 and a number above 10.
13.
13 right here. And what would be that one here?
7.
Okay, that is correct. And let me tell you how you find out. You take the class width, which is 6, and divide it by 2. So please remember that, guys. The class width divided by 2. What's 6 divided by 2? 3. You take the 10 and subtract 3, and then you take the 10 and add 3. So 10 minus 3 is 7, and 10 plus 3 is 13. 1 second, guys, just one.
Mr. Bazzi, can you repeat the how to get the first class again?
Sure. Okay. I gave you the midpoints, correct? I put 10, 16, 22. The first task that you have to do is to find the class width,
Which is 6.
which is 6, divided by 2,
Okay, which is 3.
which is 3. Now take the 10, which is the midpoint, subtract 3 from 10 and add 3 to 10.
Oh, okay. Thank you.
So if I ask you for 16, subtract the 3 from 16 and add 3 to 16, it would be 13 to 19.
Okay, thank you.
Sure, no problem. All right, guys. We're gonna learn now about the measures of center. I think you've heard of them before. The measures, there are 3 measures of center, the measures of the center of the data. I think you heard of the mean, the median, the mode, and these are the measures of center, which we'll go over right now. So if you hear somebody talking about an average, I know you think the average is to add up the number and divide by the number of quantities, but you have to remember there are 3 averages in statistics. The first one is called the mean, which is the average that you know of. The second one is called the median, and the third one is called the mode, and I'm gonna introduce the 3 of them right now. For example, why it is important, guys, to know the measures of center or the average. If I give you this data set and I ask you, how did the class do? Can you tell me right away, you know, just without doing any work, you know, what's your impression? How did the class do on average? What would you say? I mean, you have to look at the data and see how people did out of 100. It's a little bit hard, but if you know the average of the class, guys, like if the average of the class was 75, I can come back to you guys and report to you that on average the class passed the test. They did fine. But now just looking at the raw data, it's a little bit hard for me to tell. So it is important, you know, just to be able to summarize the data using the measures of center. And I want to introduce the first measure of center, guys, which is called the mean. I'm going to give you a minute to calculate the mean and see if you still remember how to do that. How do we do the mean? By definition, to do the mean, you add all the observation and you divide by the number of observations. So I have 4 values here. In order to find the mean, guys, you need to add the 4 quantities and divide by 4. So can we do this together, please? And then divide by 4.
$133,625.
If you add them up, what did you get? 133?
And then 625.
625. Make sure, everybody, that you can do that. So just add up the quantities. You can also use your calculator to do it. So I got 130,000 plus 133,500 plus 136,000 plus 135, and then divide by 4. There you go. So find the answer of the top first, guys, and then divide by 4. Next, we're going to introduce the median. The median of a set of observation is defined to be the value in the middle. And I'm going to show you how to find the median using the same example as before. But in order to find the median, guys, you have to arrange the data in order from smallest to largest. So I'm going to arrange the data in order, and then I'm going to ask you to help me find the median. Where is the median, guys, here?
The 2 in the middle.
It's right here. Exactly. It's not this value and it's not that value. So
We add them.
what do you do? The average. So
We add them and divide it by 2.
Exactly. Exactly. So here is the median. It will be. Okay, so that will be, you can use your calculator if you wish. I told you I won't have any issues with you using the calculator as long as you used it properly, guys. It will be a mistake, guys, if you put divide by 2 like this. That will be wrong. Why?
Because you didn't put the parentheses.
Exactly. Order of operation, guys. You have to add first because we need the total divided by 2. So you have to do the total first. So that would be wrong. So I'm going to clear this and do it right. And now divide by 2. 134, 250. Okay, so if you have an even number of values, guys, your median is not going to be one of the values. It's going to fall in the middle between 2 values. But if you have an odd number, let's see what happens. I'm going to do it right here. Find the median. I put the data in order. So can you tell me what the median is?
15.
Does everyone agree, guys, that it is 15? Look, cross 1 off, 1 off, 1 off, 1 off, 1 off, 1 off. There you go. So can you, which value is that? Where is the position? First, second, third, and what? Fourth value. So the median is the fourth value. If you count from here, first, second, third, fourth, it's the fourth value. Let me ask you this question, guys. If you have 37 values, where would the median be located? In which location? First, second, third, fourth, etc. Can you guys tell me? How would I find the median? Where do I go? Here we went to the fourth. If you have 37 values listed, where do you think the median is going to be? In what location? In what position? 15th, 16th, 17th, 18th?
16, 17.
18?
Okay, how many did I say I have? 37, right? Okay, let me show you how to do this. How many values do we have here? 7. Add 1 to 7. What's 7 plus 1? 8.
8.
Divide by 2.
4.
8 divided by 2 is 4. Count to the fourth value. That will be your median. Now, if you have 37 values, guys, Add 1 because it's odd. Make it even. So 37 plus 1 will be 38. Divide 38 by 2. What do you get, guys?
19.
Yeah, that's so you count until 19 value, and that will be your median. But what about if we have an even number, guys? Like here. How many values did we have?
4.
Okay, here's how you find the median. Divide 4 by 2. 4 divided by 2 is 2. Your median will be between the second and the next one, the third. Look, first, second, it was between the second and the third. So if you have 50 values, guys, and you want to find where the median is, your median will be, divide 50 by 2 will be 25, so it will be between the 25th and the 26th. And actually, I put, just a summary here about the median. Your calculator can find the mean and the median, and I'm going to demonstrate that in a second. Just 1 second.
I think you're muted.
We can't hear you.
Yeah, you're muted.
You are correct.
There you go.
So, to use your calculator, guys, you just press that and then edit. And then start entering the data into list, L1 by default. So I'm going to put L1 130,000, L2 135,000. Next value is 133,500. And the fourth value is 136,000. Okay, I put the data into the calculator. Oh, we missed one, the 130,000. I'll add it here. They don't have to be in order. The calculator doesn't care about the order. All right. And now let me show you how the calculator can display the mean and the median for you. To quit a screen, guys, look what you do. You just press the second and mode. Then you can quit. To clear a screen, you just hit clear, and then that will clear the screen for you. All right, and now let me show you how to find the mean and median. You press stat right here. There is a short video that I made available, only 5 minutes, on how to do this. So you guys always refer to this video. And then scroll over with this arrow key, guys, to calc and press enter. The calculator, if you have this calculator, this is a newer calculator, they see it's gonna ask you which list did you put your data in. If you don't see this, guys, just press enter and you're gonna get the answers. I will bring the other calculator in a little bit and show you how that works. So I need to tell the calculator that my list is in L1. Now, how do I enter a list into this calculator? You see the second key here, and then you put number 1. If you press second and 1, it will put list 1 there. The frequency list should be empty here. So just like that. So you should see this on your calculator. If you haven't used the calculator yet, this is what you should see, and then hit calculate. Okay. The first value, guys, is called the mean, which we did earlier. It was 133,625. The median, let me show you where the median is. It says MED, 134,250. So this is the mean, and this is the median. Any questions here, guys? We will be talking about the rest, of the screen later, but we haven't done enough, just to go over everything yet. All right. There is a symbol for the mean, guys. So it has a label. And let me tell you what the label for the mean is. If you have a sample, guys, and you are asked for the mean, sometimes they ask you to find X bar. X bar means the mean of the sample. And you notice here on the calculator, guys, that it did show you X bar at the beginning. The median has no symbol. So when you find the median, you just write the word median equal, as I did right here. So that's the median. You can do that by hand, but you can do that with the calculator as well. Let me tell you what the mode is. The mode is the value that occurs most often in a data set. Can you guys tell me what the mode is here?
84.
84.
84, let's see why 84, because 84 repeats 3 times. You are correct. You could have 2 modes. You could have 3 modes. For example, let me give you another example. Here I have 2 modes, guys. Can you tell me what they are?
1 and 2.
1 and 2. All right. Now we're going to give you this example, guys. And I'd like you to pay good attention to this. These are the type of questions I asked about the mean, median, and mode. Okay, we have 5 houses in a neighborhood. The values of the houses are the following: $80,000, $82,000, $79,000, $77,000. And then there's that house that sits on a triple lot that's worth $850,000. I'd like you guys to take a minute to find me the mean and find me the median. So mean value of the house and median value. I'm gonna have you do this. So take a minute, guys, to do this. We need to put them in order first, guys. Not find the median without putting in order. Okay. So did you guys come up with 233,600 for the mean?
Yes.
Yeah.
And the median is 80,000. Let me make this statement, guys, and show you how you can mislead people by using those averages. If you are a realtor and you want to sell this house in the neighborhood, so this house is on sale. Here's what you can say. You want to convince a buyer to buy it. You can tell the buyer the average price of a house in this neighborhood is 233,000, but you're getting a bargain for 79,000. Would you think this is a bargain when somebody tells you that the average price of the house is 233,000, but you can buy this house for only 79,000? Nobody can get this realtor in trouble for making this statement. The realtor is using statistics. But what is it that realtor is using to to advertise the house? He's using what? The mean. He's saying that the mean price or the average, he's using the mean when he makes, I told you there are three averages, guys. One is called the mode, one is called the mean, one is called the median. You can say the word average and you can refer to the mean, to the median, or to the mode. It's you can do that. So the realtor is making the statement that the average value, he's referring to the mean, is 233,600, but he's gonna sell the house, for 79,000. Oh, people will rush, just into buying it and thinking it is a bargain. Actually, the realtor, if he wanted to be honest, he should not be using the mean to advertise, or to market the house. Can you guys tell me why there's something wrong with using the mean in this situation?
There's an outlier.
Exactly. When you have an extreme value, guys, it's just like this. And as you mentioned, it's called an outlier. So an outlier is an example, or an extreme value is an example of an outlier. An outlier, guys, is a value that is far removed from the data set. It doesn't belong there. Look, guys, the prices are all around 80,000, and all of a sudden we have this mention for 850,000. It doesn't seem like it belongs there. Actually, the mean gets impacted by outliers. And if you want to talk about, just decent average, an accurate average, guys, we should not be using the mean, because it does get affected by outlier. Look what the outlier did here. It inflated the mean and make it about 230,000, although the average price of the house, as you can see, if you guys don't count this, you can feel that the average price of the house is about 80,000, and except for this outlier right there. So if the realtor, just wanted to do, just an accurate and honest statistics, he should not use the mean, he should use the median. What's the median, guys? 80,000. So in the presence of extreme values, the best measure of center to represent the data set is not the mean, it's the median. You should always use the median if you have extreme values. How do we know that the values are extreme? You can tell easily, guys, and there is a process that later I'll show you how to tell if a value is an outlier. I think you guys agree, all of you agree with me that the 850,000 looks like an outlier. It doesn't belong there. So we should use the median as a representative of the data set in the presence of outliers or extreme values. Okay, the reason why I gave this example, because this is one of the questions I ask, you know, just on the test. I ask the students to find the mean and the median, and then I ask you the next question, which measure is better, a better representative of the data set? So you check, guys. If you see an extreme value, tell me the median is better. If you don't see an extreme value, the mean is always a better representative of the data set. All right. And let's go over this. Continue with that. Okay. The mode. For what type of data it makes sense only to find the mode? You cannot find the mean and the median, guys. There's some type of data that it's not possible to find the mean and the median because you need numbers. Only you can find the mean and the median if you have numbers. So what type of data doesn't have numbers? So you only can talk about the mode.
Qualitative?
Qualitative data. And let me give you an example, guys. There's an example. Okay, I asked you what's your favorite color. I got a list from you guys. You list your favorite color. I cannot ask you to find the mean of this. What would you do? How do I add blue plus red? These are not numbers. I cannot ask you to find the median because they must be number arranged in order. The only thing I can ask you guys is the mode. The mode is the value that occurs most often. What value here can you see, guys, that occurs most often?
Black.
Black. There you go. So that's the mode. So for qualitative data, guys, you only can find the mode. All right, next. Okay, for quantitative data, mean or median is often preferred over the mode as a measure of center because the value that occurs most frequently may not necessarily be located near the center of the data set. So usually, guys, if you are given the choice between the three values, mean, median, and mode, you should always choose the mean or the median. The mode is usually not a good representative of the data set. And I can give you another example why the mode, we should not use the mode as a representative of the data set. And I will not be talking about the mode a lot. Watch this, guys. Okay, look at this data set. What's the mode?
27.
Oh, did I put 27 here? Okay, I'm gonna change this one. I'm gonna make it 35 because I want the mode to be 1. So what's the mode now?
1.
1. This is an average, but do you guys agree with me that the value 1 does not represent the data set? On average, let's say this is your score on the test out of 30, or let's say it's out of 30 or out of 35. Do you think the average person in the class averaged a 1 out of 35, you know, as a test score? No, that's not true. Look at the scores. Most of them are between 20 and 35. But the mode happened to be 1. You cannot use the mode to represent the data set. To represent the data set in this case, guys, you must find probably the median, because 1 looks like an extreme value here. It is an extreme value, guys, doesn't have to be very large. It could be very, very small as well. There is an extreme value. So you should refrain, guys, from using the mode as representative of the data set. Your choice always should be between the mean and the median. And in case of extreme values, use the median. That's a summary of the section 3.3, 2.3. Let's continue with that. This is a summary of what we did. If there are outlier in the data set, I just mentioned that the median is preferred over the mean. If there are no outliers, guys, you should use the mean. Is often preferred choice because it has some nice property. Okay. Now I want to show you something about the weighted mean, but I will not be asking you about it on the test. But you need to know so you can learn, guys, how I determine your grade. In this class, guys, we have weights. The tests have a certain percentage. The homework has a percentage. The quizzes have a percentage. The project have a percentage, etc. So how do I calculate your final grade? Let's say your exam 1 is 20% of your grade. Your exam 2 is 20% of your grade. Your final exam is 25%. Your homework is 20%, and your project is 15%. Let's see, do they add up to our 100? Yes, that's 100%. That's a 15% here. Okay, how do I figure out? Let's say you scored 84 in exam 1, 75 in exam 2, 72 on final exam, 100%, 100 on the homework, and 85 on the project. I need to determine your final letter grade, whether it's A, B, C, D. Here's how you do a weighted mean. This is what we call a weighted mean. Okay, I go to exam 1. How much from exam 1 I have to take and put it in the final grade? It says the weight is 20%. So look what you do, guys. You take the 20%, 0.20, and multiply it by 84. You can help me with that. So that will be what, guys? 16.8. Then you take 20% of 75. If you multiply 0.20 times 75, guys, you get 15. Then the final exam, you get 25% of 72. If you multiply 0.25 times 72, you get 18. Then you take 20% of 100. And finally, you get 15% of 85. That would be 12.75. Okay, can you guys tell me what do I do with those numbers?
Add them.
Add them. Okay, can a student help me out and add them for me, please?
82.55.
So 82.55. And let's say I say anything between 80 and 90 is a B. We know the letter grade of the students. That's how I determine that. I don't do this manually, guys. I use Excel sheet. I program it, and I just ask Excel to do this times that automatically, and it will do it for all students. This is what we call the weighted means. Each value has a different weight. So in order, just to find the mean, you take the weight of the value and multiply it, by the value, and then add them up at the very end. This is how we do the weighted mean. It's not very important. You will not have probably questions there on the weighted mean, but it's important that you have a knowledge, just of how your grade is determined. Okay, next, guys. These are histograms of data set. Okay. What can you say about this histogram? What does it look like? Can you describe it in a couple words? This one.
Symmetrical.
Symmetric. Okay, it has another name, guys. You're gonna learn about later. It's bell-shaped. And let me tell you why bell-shaped. Watch. Looks like a bell-shaped. All right. If you have a symmetrical graph, your mean and median and mode, if you are perfectly symmetric graph, mean, median, and mode are all exactly the same, and they are right here. This value. Because you can see this bar is right in the middle, in the center. The mean and the median and the mode are exactly the same. The mean is 8. The median is 8. And the mode is 8. How do I know that the mode is 8 here? The mode is the value that occurs most often. Look, 8 seems to occur about 37 times. So that's the largest number of times, you know, that 8 occurs. You can find the mode by following the tallest bar, guys. That will give you the mode. So this is called symmetric. This is another histogram, guys. Do you notice that 1 repeats 20 times, 2 repeats it 20 times, 3 repeats it 20 times, 4 repeats 20 times? This is called uniform. We're not very much interested, you know, just in this type of graph, but you should know about it. There is no mode here. I forgot to tell you guys, if all the data values repeat the same number of times, we say there is no mode. So in here, there is no mode. For example, if I give you this data set, watch. If I ask you what's the mode, well, you're going to tell me 1, and you're going to tell me 2, and you're going to tell me 3. Well, if every single value repeats the same number of times, statistician decided to make a conclusion that there is no mode. So you say that there is no mode. But if I add a 3 here, what do you think the mode is now?
3.
3. Because it's only 3 that repeats 4 times. The other one repeats only 3 times. So this is uniform. I'll give you an example of a uniform data set. If you toss a coin, guys, 200 times, head and tail, what do you expect to get? The outcomes. If you toss a coin, a quarter, 200 times, and you record number of heads and number of tails, what do you expect if you have a fair quarter, not a loaded quarter, a fair one?
About
60-40.
Why 60-40? Why not 50-50?
Because I don't know. Just that's how it is.
It should be 50-50. If your quarter is not loaded, it's a fair one. It should be pretty much 50-50. So if you get 200 tosses, you should get close to 100 heads and close to 100 tails. This is an example of uniform because you're going to get 100 heads and 100 tails. It's not going to come out 100 exactly, guys. It's impossible to be exactly 100, but it has to be very close. This is an example of a uniform data set. I'll give you another example of a uniform data set, which is I'm going to demo on your calculator. You roll a die. You roll a die 600 times. The die has 6 faces, guys. 1, 2, 3, 4, 5, 6. If you have a fair die, you should expect to get close to 100 ones, 100 twos, 100 threes. 4 should show up 100 times. 5 should show up 100 times, and 6 should show up 100 times. Let me demo this, show you this calculator program, and see if we're going to get close to this. And so on and so forth. Let's do another 50 times. All right. You can see, guys, it's not going to be perfectly uniform. You're not going to get a perfect same number of 1s, 2s, 3s, but it's very close. This is an example of uniform data. You can try it on your calculator. It's under apps. You should have this program if you like to try this one. The mean and the median, again, are in the center of the data set if you have a perfect uniform distribution of the data. Now look at this histogram. Did you guys notice the tail here? Watch. there is a tail toward the left. This is called the left tail distribution or skewed left distribution. Now I'd like you to look at this one here, and you notice that there is a tail toward the right, and this is called the skewed right distribution. So there are 4 types of distribution. I usually give students a graph and ask what type of distribution on the test. So you just tell me whether you think it's symmetric, uniform, skewed left, or skewed right distribution. You guys agree with me that the mode is going to be with this bar right here. So the value under this bar, so that would be the mode right here. If I want to find the mode here, it will be the tallest bar again. So the mode will be right there. Now, I would like you to pay attention to this, guys. This is extremely important. And actually on the activity today, there is a quiz question related to that. Okay. Let me sketch a graph and ask you this question. Please pay attention to this. That's very important one. Okay. Okay, if I ask you, is this symmetric, uniform, skewed left, or skewed right? What would you say?
Skew to the right.
Right.
To the right. Excellent, very good. All right. Now, look what I'm gonna do, guys. This is my favorite question that I always ask. I put 3 values, A, B, C. I'm not gonna tell you what the values are. You don't need to know, but you know that C is bigger than B and B is bigger than A. And let's say we start here, values 0 to whatever, 50. All right. Here's my question to you. Which of the values A, B, or C represent the mode? That should be an easy question.
A.
Okay, very good. Now, the next question is, which of the values represent the mean and which of the values represent the median? Here is the hint. I'm gonna give it to you right now. If you have a symmetric data set, the mean and the median are the same. No worry. They're gonna be exactly the same. But if you have a skewed distribution, whether it is to the left or to the right, and you don't need to take a note because it's already in the handout, the mean always closer to the tail of the distribution. So the mean will always fall closer to the tail of the distribution. Which value falls closer to the tail of the distribution? Is C or B?
C.
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 Do you guys agree? I heard someone saying B. It's not B. The one who's closer to the tail. Here's the tail, right here. So which one is closer to the tail? Do you guys agree that it's C? That would be
Yeah.
B.
Yes.
So the mean is always the closest value to the tail. So that will be, mean is C, and the median, guys, definitely it's gonna be B. And you don't need to do any work, you know, just to find out just by looking at the graph. Let me give you another example, but I'm gonna scoot to the left this time. There you go. Okay, I'm gonna label some values here. All right, guys. Same question. Always find the mode first, guys, because that's the easiest. Start with the mode. Which one is the mode?
B.
B.
B. Very good. And then the mean, because you already know that the mean is closer to the tail.
C.
C. Exactly. You guys agree that it is C because look, it is closer to the tail. Here's the tail. That's closer to that. And then definitely the
The
median
A, the median.
will be A. Exactly. This is how you can tell which one is the mean, mode, etc. I'm going to tell you, I'm going to share with you what a student did once I asked this question. Okay, one time I asked this question. The students got the right answer, but he spent about 15 minutes trying to figure this out. Look, I'm going to just give you a simple graph and show you what a student did before. I labeled 3 points and I asked the students, you know, to tell me which one is the mode, which one is the mean and the median. And I put some values, let's say here. And then I put some values here. For example, okay. To find, let's say, if I label, you know, just this value, for example, right here, guys, and right there, and right there, this one, you know that this is the mode. And if I label 2 other values, you know, this is a left tail. So the one that closer to the tail will be the mean, and the other one will be the median, and you're done. But look what the student did. The students used the calculator and put a list in the calculator. He put 7, 10 times in the calculator because 7 repeats how many times? It's 10, you can see. Then he went and put 10, how many times into the calculator? 15. And then he did 13 and put it 20 times into the calculator. And then he did 16, whatever number of times, probably 23 times, and found the mean using the mean and the median using the list, and then compare which one is bigger. That takes so much time, and you're not supposed to do it this way. You're supposed just to look at the graph and observe it and get the answer, and no need to do any tedious calculations in here. So in summary, guys, the mean will always fall in the direction in which the distribution is skewed. I put a note for you. For instance, when the distribution is skewed left, the mean is to the left of the median. And when the distribution is skewed right, the mean is to the right of the median. But whatever I said, you know, explain that, you can follow that, and you should always be able, guys, to identify which one is the mean and which one is the median. Okay? Any questions? So we learned about the mean, median, and mode. Now we're going to learn about other measures. They're called measure of variation. These probably you haven't heard of before. What are the measures of variation? And let me give you an example why it's important to learn about those measures. Okay, and I need your participation here, guys. So before I begin, I usually use this example with my students to introduce section 2.4. I'm gonna do this same example with you guys. So if you can help me out and participate with me, that would be great. Okay, let's say, guys, you go to the bank once a week and you have 2 branches of the bank located at the same distance from your home. Located at the same distance from your home. So let's say they're both 5 miles from your home, exactly 5 miles. You can go to either one, it's the same driving distance. Which branch would you go to? Let's say you have branch A and branch B. How would you decide, guys? What would be a factor that will make you decide which one you should go to? Can you elaborate on this? Yes. How would you determine? How would you make a determination? Which one should I go and do my transaction there?
Everyone is less busy.
What is it?
Whichever one is less busy.
How would you interpret that? Oh, the route, let's suppose the route is exactly the same. So it's same stoplights. It's convenient. It just takes you same amount of time to get there. I have a student say the route. Would you say, guys, the wait time is important?
Yeah.
I think the wait time is important.
Yes.
Okay, so we sent 2 students to branch A and branch B. I got 2 students from my class. We need to have who want to help us determine which branch to go to. They go and they record the wait time for 10 customers each. And they come back. So they say customer 1 waited 7 minutes, customer 2 waited 8 minutes, customer 3, 7.5 minutes, etc. They came back to the classroom and they gave us the data. We found the mean waiting time for each branch. So we found the mean. It turns out the mean wait time, the average wait time in branch A, when we found the mean, was 8 minutes. And for branch B was 8 minutes as well. Well, guys, we cannot make a determination. It's the same mean amount of time. But then a student says, well, Mr. Bazzi just taught us how to find the median. So why don't we find the median? And the one who has less median, we can go to. I said, okay. I did ask 2 students to find the median, and unfortunately, the median came out to be 8 minutes and 8 minutes each. Well, then a student says, well, we learned the 3 averages today. So what's the 3rd average that we learned about, guys?
Mode.
Mode. Well, it happened, guys, unfortunately, that it was 8 minutes and 8 minutes. We could not make a determination based, on the averages that we learned in section 2.3, mean, median, and mode. So is there something else, the guys, that we can do to make a determination? Well, the good news is there is, which is going to be in section 2.4. So we can find what we call measures of variation. Let me show you how we're going to make a decision, guys. You're going to like that, being able to use statistics to make a decision. So we find the range for your information. So now we're talking about measures of variation. There are 3 of them. I want to begin with the first one. It's called the maximum value minus the minimum value. So we added the range to the list. I asked a student who went to branch A, I said, can you compute, the range for us? So the students looked at his data set. He picked up the maximum value. He picked up the minimum value. Let's say the maximum value was 15 minutes wait time. And the minimum value was 7 minutes. So the students came up with a range of 8 minutes. Okay, let's see what the other students did in branch B. We asked the students in branch B to compute the range for us. And the students came up with 4 minutes. Now, guys, you probably can make a decision. The difference between the person who waited the least and the person who waited the most in branch A is 8 minutes. So there is quite a bit of gap. Whereas the difference between the one who waited the least and the one who waited the most is 4 minutes. So we can make a decision, guys, to go with the range and then decide to go to branch B. Because if you are stuck and you have to wait the most, the only difference between you and the one who waited the least is only 4 minutes, whereas it's going to be 8 minutes in branch A. You can use the range to make a determination and tell me we're going to use a branch B. But there is a drawback of using the range, guys. Can you guys tell me what's the drawback, if you can think of it, of using the range? Remember, the range is only you use the maximum value and the minimum value. there's a disadvantage of using the range. Can you guys think of it?
It's affected by outliers.
Okay, that's one thing. And it only takes into consideration two values, the smallest and what? The largest. And it does ignore the rest of the data set. So if you have a data set like this, watch. How many data values I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I have 16 values, but the range only consider this value and that value. And it disregards the rest of the data set. It ignores the rest of the data set, and it only takes into consideration the lowest and the largest. You can use it as a tool, but it's not recommended always to use that the tool because it does ignore the rest of the data set. So that is the disadvantage of using the range. So the range, guys, is the difference between the lowest value and the largest value. This is the first measure of variation that you should know about. Now, there is another measure of variation, which we're going to introduce now, and that's the highlight of the lesson today. It's called the standard deviation. So the range of the data set is equal to the largest measurement minus the smallest measurement. And if I ask you guys to find me the range of this data set, can you help me find the range here?
We do the minimum value.
Which is what? What's the minimum value here?
50.
50. And what's the maximum value?
100.
Yep. And that's the range. It's 50. And I heard the students saying, although the range is easy to compute, it's sensitive to outliers. Not only sensitive to outlier, it ignores all the data values except for the lowest and largest value. So that is the range. The next measure, guys, we're going to introduce, it's called standard deviation. So we're going to talk about the standard deviation. And before I do that, I'm going to put an example and tell you a little bit about the standard. Actually, guys, it is the highlight of today's lesson. This is the most important thing that you will learn today is about the standard deviation. So I'm going to just do an example on a scrap paper and then take you back to the notes. So we learned about the range, number one. Number two is called the standard deviation. Okay, let me give you a definition of the standard deviation first and tell you why this is important. Standard deviation is a measure of how consistent the data values are with the mean. It means, guys, we measure how close the data values are to the mean. If they are very close to the mean, your standard deviation is going to be small. If the data values are widely spread out from the mean, your standard deviation is going to be large. So if you want to measure how consistent, how close the data values are to the mean, you find what we call the standard deviation. And I'm going to show you an example. You will not be required, guys, to do the work by hand, but I need to show you how the standard deviation formula works, and then I'll show you how to use it on the calculator. But I will not be asking you to show me any work by hand and how to calculate the standard deviation. It is a measure of consistency. Let me write a little bit more about it. the lower the standard deviation, the closer the values are to the mean. The larger the standard deviation, the more widespread the values from the mean. All right. So this is what the standard deviation is. Let me give you an example, guys, and see if you can interpret this given what I said about the standard deviation. Let's say after the first test, guys, I make this announcement. I'll tell you the mean score on the test was 75 out of 100. That's your average score, the mean score. And the standard deviation was 20. That's a quite big 20 standard deviation. What kind of conclusion can you make, and what kind of message I'm trying, just to give you here? How would you interpret this? What does it mean for the performance of the class? On average, the class is passing 75, but the standard deviation is 20. What does the standard deviation of 20 mean? What do you guys think?
It means that the data is not that consistent with the mean.
Exactly. What does that mean? She's saying the data is not consistent with the mean. I told you the closer the value, the standard deviation, the more, the closer the values are to the mean. Standard deviation is 20, guys. This is large out of 100. So that means the data is not consistent with the mean. What does it mean for the performance of the class? What's going on in the class?
That means you have a lot of people who scored lower than 75.
And there are a lot of people who scored what?
Maybe higher.
Higher. So guys, it tells me the reason why the average was 75, there are some students who scored very low and there are some students who scored very high. And then when you do the mean, of low scores and high scores, it averaged to 75. But the standard deviation is an alarm for me, to alarm students that some of you are doing very well, but the rest of you are not doing well. So you need, just to pick up the efforts. Let me change this, guys, now. And make it 2.5. Now, can you guys say something about what's going on in the class?
It means most of the students are actually passing and closer to that mean score.
Exactly. I'm trying to tell you guys, the average of the class is 75, and there is not much deviation from the mean. A standard 2.5 is not much deviation. A plus or minus 2.5, that's not much deviation. That means everybody is performing pretty much the same. So a lower standard deviation means the values are close to the mean. A larger standard deviation, the values are not close to the mean, are widely spread. When they are widely spread, guys, you're gonna have some low values and you're gonna have some large values. Now, let me show you guys how to find the standard deviation. And again, you will not be required to find this one by hand, but let me show you an example how to find the standard deviation. Okay, we have a sample data set. I'm gonna put some values there. I'm gonna put 5 values. 15 and 3, 18. Okay. Let me walk you through the steps of finding the standard deviation. And you're gonna appreciate the calculator after I do this, guys, because it's a lot of work to do it. Okay, first of all, let's find the mean, X bar. Can a student find me the mean of the data set?
5.
I agree. If you do 7 plus 8 plus 3 plus 5 plus 2, divided by 5, guys. It's going to give you 25 divided by 5, which is 5. Okay, put 5 here, 5 there, 5, 5, 5. Deviation from the mean. How much does 7 deviate from the mean? How far apart is 7 from 5?
2.
2. It's 2 higher. What about 8?
3.
3. What about 3? It's
2.
2 points below the mean. Well, below we have to distinguish that from above. So which sign am I going to use?
-2.
Negative sign. What about 5? It's right at the mean. So there is no deviation. It's right at the mean.
Mm.
And the 2 from 5, guys?
-3.
Okay. Next step. I'll show you how to find the standard deviation. Square each deviation. Can you help me square them? So 2 becomes what?
4.
4. 3 is 9.
9.
-2 square it. It's a 4 because negative times negative is positive, guys.
Mhm.
0. And negative times negative is
Mhm.
positive. That's 9. Add the deviations. Okay. Can you help me add them, please? 4 plus 9 plus 4 plus 0 plus 9. What do you guys come up with? 13 and 4, 17 and 9, 26. All right. We're almost close to tell you what the standard deviation is. Divide. 26 by, let me write it down. The sample size minus 1. When you do a sample, okay. How many do we have in the sample, guys? 1, 2, 3, 4, 5. I said divide this total by the sample size minus 1. So divide by what? The sample size is 5. 5 minus 1 is what?
4.
What's 26 divided by 4, guys? 6.
6.5.
Finally. See, it's a lot of work. We're going to learn how to find the square root using the calculator. We need the square root of 6.5. And that will be your standard deviation. And let me show you guys how to use the calculator to find the square roots. However, when I show you the program, guys, you don't need to go through any of this. But let me escape here. Escape. Quit. Yes. Okay. Here's how you find the square root, guys. It's right here. It's in blue. When something is shaded in blue, you would have to press the second key first. So you press the second key and then go to it. And now it gives you the square root. And I'm going to put 6.5. Okay. Let's say the answer should be rounded to 2 decimal places. So what would be the answer, guys?
2.55.
2.55. This is the standard deviation of the sample. And it is labeled by S, guys. It's called S. When it comes from a sample, it is labeled as S. So when I ask you to find S, this is the formula that's built in the calculator, all the process. And now I'm going to show you guys how you could find the standard deviation using the calculator. So let's go through the steps together. Okay. First of all, guys, we have to go to stat and then edit and enter the data. Now look how I can clear L1. I want to clear L1. I just go to highlight with the up arrow and just hit clear right here. And then enter. And now this is clear. Now let's enter the data values. So I have 78352. Watch, guys. 78352. I might not have time to demonstrate how to use a stat crunch today, doing the mean, median, and standard deviation. We will do it on Wednesday. So now we got the data into L1, and let me show you how to find the standard deviation. Okay, you can quit, guys. Second and quit. You can clear the screen. Okay, press on stat. And you're gonna scroll over to calc. One variable statistic. If you have the other calculator, guys, just press that. You're not gonna see this, just press enter. That's you're done. But for me, it's telling me, it's asking me, is your list in L1? Yes, and all I need just to scroll down and hit calculate. Remember, what was the sample standard deviation? So we have to be consistent with the calculator. It was what? 2.55. Watch. All right. Do you see the first value, guys? It's called X bar. This is the mean from the sample. Don't worry about this. This is the sum of the values, and this is the sum of the square of the values. We don't need to worry about this. I like it to look at the number that's labeled S. What do you see there? What's the value of S?
2.54.
49, which if you round it, it will be what?
2.55.
Exactly. And I'll talk about the next one in a second. Let me show you what else you will get from the calculator. You will get the minimum value. Don't worry about the Q1, we'll come to it later. You'll get the median, and you will get the maximum as well. So you get more values. To scroll up and down, guys, just use an up and down arrow keys. Okay. Please pay attention to this, guys, that I'm gonna explain to you.
Can I ask a question?
Yes.
You're recording everything?
What is it? Yes.
Okay, thank you.
Yeah, everything is being recorded. Now, S, guys. So this is the standard deviation from the sample, but let me tell you about the next value. It's called sigma. This is the standard deviation if you have a population, the entire population. So if he gives you guys a data set and said, this is the population, not the sample, then your answer for the standard deviation should be sigma, but not S. But look what I put here. What did I put here? See the word here? I say sample. Once I say a sample, then you must use S as your standard deviation. But let's say, guys, I take your class as my population of students. I have 26 students in the class, and I have 26 scores, and I ask you to find the standard deviation of this particular class. Now I'm talking about the population. So if you use your calculator, your answer will be sigma. And as you can see, the two values are slightly different. They're not exactly the same because the formula is slightly different. And let me tell you where's the difference in the formulas between the two. Although this is not important when you use a calculator, but it's good to know that. Did you notice here, because you have a sample, I divided by the sample size -1. If you have the population, if he says this is the population data set, you do not -1 from the sample size. You just leave it as a sample size. So that's the only difference between the two. But again, guys, you don't have to worry about, just the work by hand. You can do that using technology. Now, I'm going to give you this example, and I don't want you to do any work. You're just going to tell me which one has a larger standard deviation. You should be able to tell without doing any work. Okay. Okay, that's the first set. Set 1. I'm ready for feedback. Which set has a larger standard deviation, guys? Set 1 or set 2?
Set 2.
Set 2.
Is it obvious to people that the
Set 2.
data is widely spread, you know, just in set 2 than set 1? Look at the set 1, how consistent the data sets are. They're very close to each other. So close to the mean. Maybe the mean is close to 8 here. But look at set 2, how widely spread the data is. Can you guys guess, what do you think the standard deviation for set 1 is going to be? Any guesses?
0.5 maybe.
Okay, let's put 0.5. Any guesses for set 2?
6.
6. Okay. Let me do the math. I'm curious now. Let's do the math together and see what the standard deviations are. So we're going to turn the calculator on. Just trying to do more practice with you guys. Edit, enter it, and then we're going to enter the data. So I'm going to go 7, 7.5. I'm going to give you extra credit if your answers are correct. There you go. Let's see. We're curious to know what standard deviation of the first set is. Okay, so you go to stat. Again, guys, calc. One variable statistic. Don't do anything. The data is in L1. Should be in L1 by default. Calculate. Okay, you were close. 0.5, but S is 1.18. Let's change this one. All right, let's do the next one. So I'm going to go to stat, edit, and I'm going to change L1 now. So I'll highlight L1 clear, put enter, and let's put the data set. 5, 6, 12, 19, 25, 27. 5, 6, 12, 19, 25, 27. Okay, let's see what it's going to be definitely larger than 1.1. Otherwise, I'm in trouble if it's not larger. Here you go. You see what the standard deviation, guys, is? 9.46. So that wasn't bad guess.
So would I still get the extra credit?
No, that wasn't close. It said, well, it has to be close. But a good guess anyway. It's 9.46. But here's my argument, guys. Did you need to do the work to figure out which one has a larger standard deviation? Do you need to waste 10 minutes of your time to do this? It's obvious. You can see it, correct? You agree with me that it looks like set 1 is more consistent with set 2. And one of my favorite examples, guys, that I give students, I said we have a coach, basketball coach, wants to hire a player, and he got, you know, just the interview data from the 2 players. Player 1 has this scoring records. Watch. In a game. So the coach watched, you know, 5 or 6 games and got this data from player 1. And then for player 2, the coach, you know, watched about 6 or 7 games, and the player 2 scored the following, you know, just on each game. Here's my question to you guys. If you are the coach and you are interested, you know, just in hiring someone who is consistent in scoring, that means you want this player, you know, if you can get 20 points from this player on each game, you want to guarantee that you will get the 20 points every time, or 15 points, whatever. Which player would you hire?
Player 1.
Do you guys agree that it should be player 1? And what's the reason we do hire player 1?
He's more consistent.
Because the standard deviation is lower. And look at the player 2. He could have a bad day, but he could have some good days, 35. So you're taking chances with this one. But look at this one. If you hire player 1, you're going to get an average of 18, 19, and probably 20 points on each game, simply because he has a lower standard deviation. So I hope, guys, you understand the link of the standard deviation to the data set. Consistency means lower standard deviation. Not consistent with the mean means higher standard deviation. Okay? And as I said, guys, S is a representative of the sample standard deviation. Sigma, it's a representative of population standard deviation. So if I give you a sample data set, you find S. If I give you a population data set, which is not usually the case, you find what we call sigma. This is red. If you read it, it's red, sigma. It's a Latin letter, guys. So this is the standard deviation. There are 3 measures of variation. I talked about the range. I talked about the standard deviation. Now there is a 3rd measure, guys, number 3. It's called the variance, but it's very easy to explain. The variance is the square of the standard deviation. So guys, if S is called the sample standard deviation, can you tell me what do we call the sample variance? What's the simple? You should know. So the variance is the square of the standard deviation. S is called the sample standard deviation. What would you think the variance of the sample will be called?
S squared?
Yep. Called S square. You just square S. Let's say S is 5. S square will be 25. That's the variance. Now for the population, sigma is called the population standard deviation. I'm sure you guys know now what we're talking about. Now population variance. It will be called sigma squared. Your calculator does not find S square and sigma square. If there is a question in the book, guys, to find the variance, you find S, and then whatever S is, you square it on your calculator. Let's say S is 2.55 and you want to find the variance, you simply do this, guys. There you go. Let me just clear here. 2.55 times 2.55. And here you go. That would be the variance. Calculator doesn't display the variance. It displays S, and it assumes the students know what to do in order to find the variance. Okay, I'm gonna wrap this up soon. Okay, I was planning, guys, and doing this activity with you today, the quiz that I sent you. Well, good, it worked out actually this way. We didn't, so that's gonna give you a chance to look at the activity. I emailed it to you. And what I'm gonna do on Wednesday, after I complete parts, just of section 2.5, I'm gonna break you out into a breakout room, have you discuss the answers of the activity, and then I'll have you come back and do the answers using the Socrative app. So you have time now to look at the activity. I sent it via email. Probably some of you did not check their email yet, but do that, just before the Wednesday class. Try to do the problems on your own, the ones that you can do. There are some that you can't yet because I haven't finished everything yet, but start working on it, and we should be able to do the complete activity on Wednesday. Just one thing, guys, about the standard deviation and the variance. If you have a data set in dollars, your standard deviation will be in dollars as well. But can you guess, guys, what would be the sign of your variance? The variance is the square of the standard deviation. What do you think the sign will be? The unit.
Dollars.
It's a square. We're squaring the standard deviation. If the standard deviation is in dollars, but the variance is going to be in what? Dollar squared. And that unit doesn't make a lot of sense. So what I'm trying to tell you guys, we don't use the variance much. We use the standard deviation because it has the same unit as the data set. And this is a comment that I put here. The standard deviation for a set of incomes would be in dollars, whereas the variance would be in dollar square. Okay, so we should always use the standard deviation because it has the same unit as the data set. Now, can you guys tell me what's the standard deviation of this data set? What do you think the standard deviation of this data set is without doing any work?
0.
Yes. Do you guys agree that it's 0? Because the mean is 7 here. If you find the mean, it's going to be 7. And all the values don't deviate from 7. They're exactly at 7. So the standard deviation is 0. So if I come to you guys at the next test, which usually doesn't happen, but let's say it happened, and I tell you the average score on the test was 85 and the standard deviation was 0, what kind of conclusion can you make? That everybody scored what?
85.
85, exactly. That's what the standard deviation mean. To close my remarks about the standard deviation, let's say if someone complain, just about purchasing, just food cans from a store and complain that the weight is not accurate. The can advertises 12 ounces, but the consumer suspect, just that there is less than 12 ounces in there. When you make this complaint, to verify, whether this complaint is valid or not, this is what they would do. They would get a sample of cans. Let's say you go to the store and get a random sample of cans from the products that the consumer is complaining about. They weigh each can. Let's say we get the following weight. Ounces. Okay, we get those weights. You're not gonna get exactly 12 ounces, guys. That's impossible. You will not get a weight of exactly 12 ounces. That can't happen because it's gonna be slightly more or slightly less, but it can't be too much less. Then the consumer will have a valid complaint. So what they do, they get the sample, they figure out the standard deviation. Let's say the standard deviation turned out to be 0.05 ounces. If the standard deviation, guys, is 0.05 ounces, do you think, just the consumer has a valid complaint? What do you guys think? Yes or no? Is the standard deviation 0.05 ounces low?
Yes.
It is a low number. If it is a low number, guys, it's not a big deal as long as it's low. That means that the values are consistent with the mean. But let's say S turns out to be this, or 1.1 ounces. Is this too much for a can that should hold the 12 ounces? Yes, there is a big deviation here, guys. And then we have a serious problem in this case. If the standard deviation is large, then the one who's packing the food or packaging the food, just will be in trouble, just for sure. But if the standard deviation is very small, I don't think there is any merit, just to the complaint, because there's going to be always a standard deviation. As long as it is small, then the data will be very consistent with the mean. Okay, that would be it for today. We'll continue on Wednesday, guys. We'll finish section 2.4 and start 2.5. So, and I'll send you, just some information about the reading for 2.5 for Wednesday, and I'll make the recording. Okay, I think I was muted for a part. Anyway, guys, so I'm gonna stop here. I'm not gonna hold you, just more beyond 11:30. So what I was saying, we will continue on Wednesday with, we'll wrap up 2.4, and we have one more section, guys, before we wrap up the entire chapter. What I like you to do, just do as many questions as possible from the quiz that I emailed you this morning, the activity that we're gonna do on Socrative. And I will be sending you a link to a video for section 2.5 that I would like you, just to read before you come to class on Wednesday. And I did take care of attendance already from your screens. So you're all set, just for attendance. You don't have to worry about that for today. And actually the good news, until the last 15 minutes, we have perfect attendance. So that's good. All right, you're all set.
Is the homework still due tomorrow?
No, I'm making it extended till Wednesday. I'm gonna do it right now.
Okay, thank you.
See you guys.
Thank you.
Thank
Probably
you,
I'll do
bye.
Thursday as well. Probably give you another day or so as well.
Nice, thank you.
Thank you.
Okay.
I'm talking about chapter 2, right?
Yeah, yeah. I'll
Perfect,
do it
thank
right now before I forget.
you. All right, beautiful. Thank you, man.
Take care, guys.
Bye-bye.